Hey guys, in this video we're going to be using the Bernoulli equation again, this time with regard to a rectangular open channel. So here's our open channel. We've got the surface of the riverbed on the bottom there. There's a slight incline as we go along, and it raises up 0.2 meters. So we've got a rise in the bed elevation. The water or the surface of the fluid is observed to rise from 0.8 meters to 1.2 meters, and we've been asked to find what the flow rate is. The rectangular channel is 2 meters wide. So we know that Q equals VA, so by solving the Bernoulli equation for V, we can end up with the volumetric flow rate, which is what we've been asked to find. So going through the same process for Bernoulli's equation as we've done before, we choose a datum. Let's say the bottom of the channel down here, that's going to be our datum. So that's the datum. Then we choose a streamline. Since the top of the channel is exposed to the atmosphere, picking a streamline along the top will simplify our calculations. We can equally do it along the bottom, but we'll have to find the pressures, which will be easier to do if we just take it along the top. Then our pressure will reduce to zero. We will have to do less in our calculations. So here's the Bernoulli equation. We're finding pressure, velocity, and height at each point. So our point 1, which is here, point 2 is there, it's along the surface of the fluid. At point 1, pressure is 0, velocity is unknown, and height is 0.8 because our datum was along the bottom there. So that's 0, we're going to call that V1, and 0.8. For point 2, our pressure is also 0, our velocity is unknown, we're going to call that V2, and our height Z2 is 1.4. Remember, it's at the bottom of this part of the riverbed, so that will be 0.2 plus 1.2. 0, V2, and 1.4. So we sub that back into the Bernoulli equation. That will be 0, that will be 0. Our V1 will remain as V1, V2 will remain as V2, Z1 will be 0.8, Z2 is 1.4. That's it there. We've got two unknowns, so we know we need another equation. And we're going to go back and use this equation here, Q equals VA. We know that our inflow must equal our outflow because there's nothing taking up water, everything's flowing from one end to the other, so there's got to be the same amount of water going in as there is going out. So our Q in is Q out, so our V1A1 is going to be V2A2. So we're establishing that equation. We know our area. Our area here is 0.8 by 2 because the channel is 2 meters wide everywhere, which is a consistent length. So here will be 1.2 by 2, and we'll then have two equations to use, and that will be 1.6 V1 equals 2.4 V2. Rearranging that for V1, we'll have 1.5 V2. So we'll sub this into the Bernoulli equation, which we have up here. We'll sub in V1 equals 1.5 V2, and we'll end up with plus 0.6, and we take that over the other side, reduce that so that we have V2 on its own, and we'll get V2 equals 3.07 meters per second. Since the question asks for the flow rate, we need to put that back into our equation for flow rate, which was Q equals VA. In this case, we're using V2, so that will be 3.07 times our area, which was 2 times 1.2. And we're left with a flow rate of 7.37 meters cubed per second. So that's it for now. We'll see you in the next video.